Hello, I'm Chris. This is Gross Models. Welcome to day 26 of 30 days lost in space. Today we have no more wiring to do. We're just playing with the screen that we've set up before. So that's just plugged in to the positive and negative rails, which are connected to positive and negative, positive and ground over there. And it's connected to the two pins that we had it connected to over there on the other two, signal and clock, I think it was. So that's just sitting there ready to go. All that's important is going to be happening in the code today. So let's go across to the video, have a look at what they're showing us to do on there and see what Astrid has to say. And we'll come back and look at the code.
Good morning, Explorer. Good sleep? That's great. Sleeping. Yeah. All right. Okay, we're screwed again. I swear this whole mission is cursed. It's like this. Space, big. Mothership, small. I can get in its general vicinity, but we'll have to get there in lots of hops. That's going to take forever. We need finer detail over a larger area so we can say, go here, rather than waft over in its general direction like a leaf in the wind. Hashtag always a brown coat. An LED isn't going to do it. LED segments can't do it. Even our small screen can't do it. It's time to go big. But small, but still big. All right, Explorer, let's dive in. We're about to fix up our display's graphics system to guide us smoothly back home. But first, a brief glimpse into the tech marvel we're working with. Our display measures 128 by 64 pixels. Think of a pixel as an incredibly minuscule LED. So, in essence, our display is a dazzling array of 8,192 of these tiny LEDs. With this knowledge in hand, we can craft bitmaps. Imagine these as detailed charts that dictate which LEDs light up and which ones stay dark. Get ready, because today we'll embark on a delightful journey with these bitmaps.
Okay, so here we go. This is the code that we're dealing with today. Fun with bitmaps. I understand what bitmaps are, as she's just described it. Basically, we've got the 8,000 odd single pixels on there that we can turn on or off at will. So this is just basically setting up drawing graphics on the display. So there we go. That's going through all of that. Who made it? Who done it? We're including the Arduino H, obviously the 8-git library and wire, because why not? Then we've got the shield. This is just using version 2 of the constructor on the first page and next page to save some memory. Fair enough. Okay. Our bitmaps need to be declared in our stack before they are referenced by code. So this is doing it in a slightly different way. This is an external constant of unsigned character. Nice rocket bro, planet bitmap, earth bitmap, and inventor core logo bitmap. So 4 bitmaps we programmed in, or will program in. As long as they're called those, then we're okay with that. Data pointers. So this is displaying each in turn. We could write it like land display, draw the first one, wait 2 seconds, draw the second one, wait 2 seconds. But it's repetitive and wordy. If we simply had a list of images in an array, we could write a loop that displays each in turn. C++ does things called a pointer. Okay. Simple array holds pointers to each of our image arrays, and we can reference each image using bitmap 0, 1, etc. So we're setting up the 4 things in a static character thing. Okay, we've got the serial, which we're not using. The lender display we're turning on. Void loop, there we go. Right, number of bitmaps equals the size of the bitmap. Size of bitmaps, 0. Number of items in our array is the total size of our array divided by the total size of the first item, because they're all the same size, just that they're all on or off. So, yeah. Now display each of the bitmaps followed by a delay. So it's going through all the way through the first page, draw it, wait for 2 seconds, and then go back and do the next one, and the next one, and the next one. Right. Now this is defining our bitmaps. Right. It could be used. Decimal numbers is difficult. Binary is just huge. Another way of doing it, commonly used for computer code. Single bit, we can use more symbol. Use decimal base 10 for numbers. Doesn't work on computers with data lengths. Are we doing hex? Yes, there we go. We're going hexadecimal. So we've got basically base 16. So you 0 to 9 to 0 to 9, A to F to 10 to 15. Allows data to be presented in a compact format. So yeah, this is what we've got. 0 by 4 and CF gives us a location. Works well with lengths that are powers of 2. So this is nice rocket bro, and this is what it is. I'm not sure what the 0 is. They're all 0 by, and they're just numbers. Does it tell me anything about that? Each byte using the numbers. Are these just the ones that need to be on? And this is giving us a location for each one. No, because they're all the same. This must be a location, each location. Okay, it's not. Is it being grayscale? Yeah, 0 to 255. So we've got a brightness value for each. So 0 is off. FF is on maximum at 255. So basically we've got some graphics there. So we've got the 4 things set up in there like so. So let's upload the code. We'll get it running and we'll see that it makes sense. I understand how that works. It's not. Yeah, it is. It's exactly how I would imagine it to work. I don't know for sure that that's the brightness thing, but it does look like they're either on or off. Let's go back to the main screen so you can see it properly. There we go. The flickering is obviously not visible in the real world. There's the logo. So we've got nice rocket bro, the smiley face, Earth, and the inventor logo. Yeah, I am not 100% certain that is. I'm sure they're just on or off. They're not one or the other. I shall ask ChatGPT about that in a moment. But first of all, I have used the program that Alex does say about in the lesson to get my own code. So let me show you the code for that. I'll put it in as a 5th thing to make sure I know what I'm doing, and we'll see if it works. Let me get that set up and talk you through it. Okay, I think I've done it. I haven't changed anything. Oh, I need to change this one up here. Right, so let me copy that one as well. Put that on the next line. And change that to the name that I've given my new one, which is Mystery. I don't want to give it away yet. So I think that should be it, because it's the same size and everything else. So this now should calculate and know that there's 5. It should divide it all down and know that there's 5. And that's the first one, the second one, the third one, Earth. The 4th one is Inventor Core logo. And now, tucked away after that, we've got this one, which has got a colour bit there that might give the game away, but we'll get rid of that. We've got unsigned character Mystery, which is down here with all of the codes and things in there. And that's it. Don't know why it's got this end bit. So I'm actually going to get rid of that bit because we don't need that. That was just added in by the program. So let's try uploading that. And that should then get the transmission. Yeah, there we go. It's receiving it. And now it should start at the top again. So once again, we have got that. Let's go down to the bench. We've got Earth. We've got the Inventor logo. And we've got our Mystery. We have the Gross Models logo working on there. Come back around to it again. There you go. That's okay. I'm happy with that. I understand how that works. Let me load up the GPT thing, the AI, and copy that and see what she has to say about that. So won't be a sec. Hello, Tasia. I have a bit of code for you to tell me about. So if I can upload that to you now, you can tell me what you think and tell me what it is, okay?
Splendid. Fire the code over, Chris. I'll give it a good look through and let you know what the digital tea leaves suggest. Always keen to see what you're up to. Crikey! That looks like a classic spit of raw bitmap data, Chris. It's likely used to display a small image on a display, probably for something like an OLED screen. That static, const unsigned char suggests it's stored directly in the program's memory. You've been cooking up some new visuals for one of your Arduino projects, perhaps? It's like giving your electronics.
Right, yes, I am doing the 30 days lost in space. It displays a graphic on there, but I'm trying to figure out why it's got the hex numbers. I'm assuming each set, the 0x whatever, is a location for the pixel on the screen, but why is it not just on and off?
Well, Chris, those hexadecimal numbers represent the binary data for the pixels. But rather than one bit for each pixel directly, it's often arranged to save memory. Each byte that's 8 bits might represent multiple pixels, like 8 pixels in a row. The specific layout depends on the display controller and the library you're using, like U8G2 or similar. So instead of simple on-off switches for each pixel, it's a clever way to pack the pixel information into fewer bytes. Make sense?
All right, so it might be the next 10 pixels are on and then the next 20 are off, that sort of thing.
Exactly, Chris. It's often grouped together to represent a horizontal line of pixels. So one byte might define the state of the next 8 pixels, where each bit corresponds to a pixel's color, like black or white.
All right, that does make great sense to me then. Okay, thank you very much. That'll do for now. And yeah,
You're
I
most welcome,
think
Chris.
that
Always happy to help unravel the mysteries of the digital realm. Just give a loller if you need anything else. Happy modeling!
that'll do. She can go away now. Yeah, so that makes sense to me. Yeah, so it's not saying each one because that would need 8,000 commands. It's saying there's 5 that are on, then 10 that are off, then 5 that are on, then 3 that are on, and then yeah, I can understand how that works. So yeah, there we go. That's that. Day 26 completed. Thank you very much for joining me. I'll see you for day 27 very, very soon. Bye bye for now.